hoo hoo hoo. Ho ho ho. Alright. New day, new problem, new streak. 0-0 streak currently. I think I can maybe rename the streak counter as like rethink about it as the number of days since the last hard problem I've encountered that I was stumped by. That'd be pretty accurate. Anyways, it's been 0 days since that has occurred, and let's see if I can climb over the easy and mediums to get to the next hard. Alright, medium minimum cost to convert string part 1. You're given two zero-index strings, source and target, both of length n and consisting of lowercase English letters. You're also given two zero-index characters arrays, original and changed. An integer array cost, where cost at I represents the cost of changing the character original I to character changed at I. Okay. Given a source and a target. Original and changed. Interesting. Okay. You start with string source. In one operation, you pick character x from the string and change it to character y at the cost of z. If there exists any index j such that cost at j equals z, original j equals x, and change at j equals y. Okay, sure. Return the minimum cost to convert the source to target using any number of operations. It's impossible to convert source to target. If it's impossible, return -1. This is a medium? Oh my god. Alright, anyways. ABCD to ACBE. And these are the original values. Okay, so it's possible to have like an original value that goes to two different kind of change values. C goes to B, C goes to E. And there's some cost associated with that. All A's goes to all B's. A can go to C, and then C can go to B. So that means A can go to B with 1 to 3. With the total cost of 3. And then you have to do that for all 4. So it's a total cost of 12. Okay. So what I'm thinking about here is based on the original array and the changed array, I might want to just create like a square matrix that gives the lowest cost from any input letter to any output letter, the lowest possible cost of that conversion, because that will eventually what's going to happen. If there is no pathing from the input to the end letter, and that's necessary in the target to target from the source to target, then obviously you return -1. Okay, so maybe it's not that bad. So derive square matrix that is where input equals row equals kind of starting letter, and I guess the row is the input. Let's see, where row column is the input letter, the column is the output letter, and where position of row column is that, and the matrix at that position is equal to the lowest cost to convert. So I just need to do that kind of transition matrix. Transition matrices. So I mean, it's possible that there's like a input letter to output letter that is direct. Like maybe A to B is 2 here, but maybe there was another pathing like A to C, C to B that made it smaller than that. A to B was 20 and A to C, C to B was a total of 10 or something. How would I create this matrix? I think I want to do a graph, like a feel like I want to do a graph. So how to do something where just A to B, like there's 3 letters, A, B, C. A to B is let's say 3 or it's 5. A to C is let's say 1. C to B is let's say 2. How do I somehow update A to B to be 3? How do I update A to B to be 3? For every starting letter, so would I like to create a graph from every starting letter? Create a graph from every starting letter. Would that work? So I put I put 1 AC on a heap, 1 AC, and then I put 2 CB, 5 AB. Would this work? So then when I evaluate things, I go 1 AC, since it's the lowest cost in the heap, then I know that there can't be anything lower, any lower cost path between A and C. Then when I do 2 CB, I connect those. And then somehow when I perform the connection to C to B, I need to already connect A to B to be 3. I think. Do I want to store the backwards connection from a particular node? The node being a letter. So when I do 2 connects, 2 is the cost of going from C to B. I somehow have stored the A that C has previously connected with A, like the previous connections to this letter, and then I have to iterate over those. That seems possibly very slow. C is connected to A, and now B is connected to A by that cost. And then I'd have to, if there was anything prior to that from like A, let's say Z connected to A, then I have to go Z to B, the updated cost. Guess this is probably not a very, yeah. Building this thing is the main, building the square matrix is the main cost of this algorithm. Once this is built, then it's just O of n to determine the cost of the source to target thing. So the question is how hard this is going to be. Apparently there's 2,000 connections here. 2,000 connections. Huh. So if I, so really this is all about like, if I imagine this as a weighted graph, you have a graph of connected nodes. Each node is a letter. I guess it's a directed graph. Directed graph. Each node is a letter. There's direction from the source letter to the destination letter. There's a weight to the edges. And then I need to build a matrix that is for any given starting node and any given ending node. What is the shortest path among any edges? And I need to do that. I need to build that matrix. Oops. So you're starting with your smallest cost edges, and then each time you're starting with your smallest cost edges, A to B, no, A to C, you say that's 1. And then go to your next smallest cost edge, and you see it's 2. See it's 2. I mean, do you need a back propagate? And you have to go to A to B and say that's 3. Think you have to do that? How else would you create the connection so the next time you see A to B and you see it's 5 that you don't want to update? You have to update backwards. You have to update backwards. Oh, I somehow don't recall seeing a problem like this. Although something like find the shortest path between I guess maybe in general when I see a weighted directed graph, then there's some sort of source node and some destination node, and just trying to find the single shortest path between those two nodes, which is a strictly less complex version than this, where I need to find the matrix that is the shortest path between any node to any source to any destination node. I think that's why I haven't seen something quite like this. It's generally a defined starting and ending letter. How would you do the back propagation? A to C, C stores that A is connected to it. Guess you could do that, right? Why couldn't you do that? C stores that A is connected to it. And then you do, and then when you do C to B, you connect B to C, and then connect B to A by extension, and B to anything before that by extension. Although this doesn't seem like a medium. Although I guess this doesn't seem as difficult as in hard, I guess. Okay, let's get something coded. Let's say the cost matrix. This is going to be a square matrix. Guess it's going to be a 2D matrix. Where your row column is equal to input letter, output letter. And obviously it gives you the cost for that transition. So I guess it's going to be times 26. Initially the cost will probably be infinity. Infinity times 26 for every row. That's not what I want. I think I also want like a graph. And maybe for the graph, maybe I just need to somehow have a connection. Maybe it should be connected. I want like a forward connection and a backwards connection. Maybe I just need the backwards connection. Backwards. I'll just make this a default dictionary to just keep it simple right now. I might change it to something like a matrix once I want to optimize for memory or speed later on. There should be a set of, I need backwards and forwards maybe? I just need backwards, right? Set of prior connections. Maybe do I need to actually do forwards as well? Like if I had one A, C, and there was another one that was, let's say, C to D is 1. Is that what I'm thinking of right now? No, let's say Z to A is 1. Z to A is 1. So 1. So if I do 1 connects A to C and one connects Z to A. And at this point I should probably do one connects Z to C, or like 2 connects Z to C, total cost. Total cost of oh gosh. One goes AC, and then I have to update everything that's connected to C. Fuck. And then everything that's connected to their parents. Fuck. That's disgusting. Like it would have to be like, this means that Z connects to A, and then somehow Z connects to C. And then Z connects to everything after C. But then everything after C, like if Z is connected to previous things as well, then every one of those has to connect again. Oh my lord. Huh. What the heck? What the heck? Let me think here. Source target consists of lowercase letter. Is it possible to have duplicates? Maybe it is actually. There's nothing here that seems like there couldn't be a duplicate kind of source target letters or original changed. Oh gosh. One connects to C, cost 1. 2 connects C to B. Somehow A connects to B, cost 3 right then. Do 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 do. A to E. Impossible. Do 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 do. How is this normally done? Put your starting letters on the stack. Put your starting letters on the stack. Evaluate your lowest cost. One goes AC, 2 goes CP, 5 goes AB. Okay. I think I want to handle the duplicates first. I don't like the fact that this is not it's not, there's no guarantee that all the transitions between original to change is unique. Like it could be AC costs 1, AC costs 10. Don't like, I don't like the problem in general, but I don't like having to deal with that kind of buggy, irrelevant transitions. Having to try to figure out when I'm dealing with that. So I think I might want to get rid of that. So I'll do something with tuples is equal to this and create the tuples array. N is the length of cost for n in range, or index in range n. I wonder if I should just add this to the set and then create the sorted list from that set, maybe. Guess that's fine. Steps to add to the set so it gets rid of any duplicates. The cost, which is cost at this index, and maybe the original letter and the end letter. Then I'll say tups is equal to sorted of tups. Okay, cost 1 to transition CE, 2 to transition AB, 2 EB, 2 BC, 2 CB, or 5 CB, 20 DE. Okay, that's kind of what I'm thinking about. I wonder if I should just change it to offsets, maybe. It's gonna be harder to debug. Well, I might save that. Although, I guess maybe, I think offset is what I want, right? Ord, offset is equal to ord of A, or maybe it's just the int. Maybe it's just be int of this thing. Is that right? I don't think I can subtract with this. Yeah, I think it should be offset equals ordinal A, and I think this should be ordinal of this minus the offset. Alright, 1, 2, 4. 2 being C, 4 being E. Uh, 1 C to E. Okay, yeah. Let's go ahead and just keep the previous possibility. Oh gosh. Can't make up my mind. Previous possibility being just the original letters. case I wanted to go back to looking at that. So if I have these values, how do I build my graph? Got rid of the duplicates, sorted by lowest cost. Actually, I didn't get rid of duplicates. What am I doing? Fuck. Oh, I didn't get rid of duplicates at all. Did not get rid of duplicates. Oh my gosh. What's the best way of getting rid of duplicates? Input, output. Sort my matrix. Sorted tuples is not gonna do it. Fuck. Okay. I think I do need to just have a square matrix. Oh gosh. So if low cost, so let's say cost cost start letter end letter is equal to cost index. I guess it'd be ordinal this thing minus offset. Yeah, let's use indices here. Oh gosh. Fine. Use k for the index variable. Ordinal of original at k minus offset. Ordinal changed at k minus offset. It's possible to actually do the same, isn't it? Okay. Original and changed for different letters. At least that's solved. I think I want to do something like if cost is lower than the lowest cost from starting letter to ending letter in the matrix, low cost from the starting letter to the ending letter is this value, and then I need to iterate over the matrix again and form the tuples based on it. So for every start letter in range of 26, for every end letter in range of 26, if the low cost of the starting to this ending is not infinity. Oh, what am I doing here? Holy cow. Then tuples append. I guess it's append. At this point, I don't have to worry about sets, so just have a list here. Tups append. The low cost from the start to this end. Start end. And then I'll go ahead and sort the tuples. Int object is not scriptable. What are we talking about? Not scriptable. Cost at K. That should be. That should be. Well, cost is cost is the name of the array. I'll just call it C, I guess. Okay. First time I noticed that cost was the actual name of the array. Really should be plural. It should be costs. How 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 funny looking. Cost at K. Low cost start to end. Oh my god, I'm such an idiot. Okay. Alright, now I got rid of duplicates. Duplicate possible original to change with lower cost. Okay. How to handle the tuples. Ain't no way. A to B. A to B. Can I build? So if I just assume that I start with every node, so start with interesting. So if I start with the graph, where each node is its smallest direct weight already from the list in the cost array, I start with that graph and then build from there. How redundant do I need to go through? How redundant do I need to? So if I go through that, and then what I do, I put on the stack every starting letter, and then just iterate from each starting letter. Put on the stack A. Let's say A goes to B, A goes to C. And then I put on the stack B, evaluate, put on the stack starting letter, and then what? Put on this. When I evaluate A, I look at all its neighbors, and its A is connected to B and C. A is connected to C with 1, A is connected to B with 5. Or A is connected to C with 1, A is connected to B with 5. And then what? And then I put on to stack everything that's connected to C. how does that resolve things? Wish there was an easy draw tool. Guess it's what I'm thinking about is having a paper and pencil. A is connected to C. A is connected to C, is connected to B. C is evaluated. C is connected to B. Okay, how do I think about how A is connected to B? If I have a bunch of lines, why is this like this? Why is this like this? A is connected to C, A is connected to B, and then C is connected to B. So how do I update A is connected to B to be 3? Seems like a pretty simple problem. A is connected to C. A is connected to B. A pushes C and B on the stack. Pops C, C pushes B on the stack. Interesting. A pushes 1C onto the stack, pushes 2B on the stack. And then when C is processed, C pushes, no, so A pushes 1C on the stack, 5B on the stack. When C gets processed, C pushes, maybe I need to just assume that starts with A, like for each, maybe when I'm building this I need to just start with some initial node and build from there. Would simplify things. A is the starting node. A goes to C, so that'd be 1C, 5B on the stack. C pops, 1C pops off the stack for every node that C is connected to. Every node that C is connected to, I push the total cost plus that node onto the stack if it's better than what's currently seen by A. Does this work? Is it too slow? I mean, it's 26 by 26. 26 by 26. It'll probably update. 1C, 2, 5B, 3B, 3B gets popped off. 3B gets popped off. And then everything that's B is connected to. Oh me, oh my. Guess I have to go with it, right? What else am I thinking of? Like low cost is the same thing as less cost. I guess I think I need to do something like for every kind of source. No, source is already used. Start in range 26. Heap should probably be like 0 start letter. And then for, I guess this would be while heap. I think I need to have something that keeps track of the best so far. I guess the best so far should just be referencing the low cost. Gosh. Okay. While heap. And it's I think it should be if low cost from the start letter. Actually, let me pop this off the heap. Maybe this should be a deck actually. WQ. No, it should be heap. Heap is heap. Let's see, total and current letter is heap pop. If low cost from the start to the current letter is already smaller, then this total, then ignore. It's kind of outdated information from the heap. Otherwise, we should say something like low cost start to current is equal to total. This will update like A to A to be 0, but that's fine. I don't think that's ever going to happen, right? I can handle that. I mean, S A to A is 0. Technically, the cost of changing a letter to itself, so yes. Sure. But if it was anything else, then it's probably workable. So for every, how do I store neighbors? There's a matrix and there's like a graph I want to build. Yeah. And I need to keep track of both. Alright, let's go ahead and just build the buffer graph. I think this can be default dictionary. Sure. Let's just build the freaking graph. I'll just use like, just getting tired. I'll say graphic. I'll use the tuple as the key here. Tuple is to start end. Is that right? No. No, that's not what I want. I think I want to have a graph of a list, maybe. Graph of a list that's 26 long. It's not quite either. I want a default dictionary of the default dictionary of an int, maybe. Default dictionary of default dictionary. Oh Lord. I just don't want to do this. Am I referring to this idea or this problem? Low cost. This is not terrible if I just go through every single letter combination. Yeah. It actually does feel terrible. How else would I do it? A to C. Low cost from the current letter to the other letter is equal to infinity. Skip it. Okay. So let's say, at this point the other is actually valid. So now I need to evaluate. So current is the letter. Current letter to the other letter is infinity. So if there's a smaller value, then I need to compare the start letter to this other letter. So if the total, let's say the trying to find another word for cost that I haven't used. Total cost. Let's say this part cost. The part cost is this low cost from the current to the other. If the total plus this extra part is less than the low cost from the start to this other letter, then this needs to update. Low cost from start to the other letter equals this total plus cost, total plus part. And then I need to add this to the heap. Heap push. Cost is total plus part. And then the other letter is the thing I'm considering. What the other letter itself? I guess I probably should have if other letter not equal to current. The letter is not the same as the current letter. Or no and. No, let's continue. Oops. Other letter is equal to current letter or low costs, or the low cost is infinity. So there's no transition there. Skip it. To do part low cost current other total plus part. Does this work? Does this work? So this is gonna go everything that's connected to A and update everything connected to A all the way down the line back to A and reduce the cost. I don't know if this works completely. If I do this from every start letter from A to Z, I think the issue is like if I do something where, let's say, what am I thinking of? Let's say there's another letter that's Z. And somehow Z to A gets updated last. Let's say Z to A currently is 1,000 if I go directly. But Z to A could be 3. This path doesn't get updated. This path from Z to A doesn't get updated until Z is the start node. And then there could be some cascading effect from that. Is that right? Maybe that's wrong. Maybe I just already solved it. Every possible start node, I'm trying to build everything the lowest cost from that start node. So maybe I don't need to worry about that. This might be right. This might be it. Total plus part is less than low cost from start to other. Update the lowest, push it, and then let it sort itself out later on. Yeah, I'm building it. It's building it piece by piece. Okay, let's give it a whirl. So I think this might actually have fully built it. For every, let's say, n is the number of costs. Let's say w is the length of the words here. For every index and range of w, let's say start and n is equal to the ordinal of source at this index minus offset, ordinal of end at this index minus offset. So those are the indices. And then if the low cost from start to end is infinity, then return that it's impossible. There's no path. Else answer plus equals low cost of start to end. Return the answer. Ah, good old misspelling. Good old misspelling. Sacre source. Is that how you spell source? Okay, good. Int object unscriptable. Oh boy. And source and target is the other array. Succotash. Was this trivial? This was trivial. 30. Oh, I guess I return -1. Nope. Case 2. Well, case 2 should have been easier case. A to C, A to B. Okay, let's go ahead and just try to figure out what happened in case 2. So start was 0 for A, 0, 0. Low cost start current. Okay, let's go ahead and just print out the heap each time. It's not great. Not great. Not gonna lie. There should probably be a heap at some point here. Why is it going through every letter? Why is it going through every letter? 0, 1, 0, 2, all the way to 0, 26. Ah. 0 is the cost start. If the low cost is less than its total, continue. Low cost is equal to this. every other in range 26. I guess I should probably skip it with the current letter as well. So if other equals source, if other equals start. Obviously it didn't change much. Other equals start, other equals current. Part is equal to low current other. Low class current other equals infinity. I mean, that is the case for most of it, right? Low class does have what I think it has now. Has a bunch of infinities. Zero. A to A, B, C is A to C is 1. B to A, B is 2. What's this? Why is this one 2? Should be C to B is 2. Oh no. Okay, yeah. This is B. This is C. C to B is 2, sure. Okay. Part equals low cost current other. If the total plus part is less than the low cost, low cost from start to other. Low cost from start to other equals total plus part. A push total part. That seems reasonable. When is it pushing stuff onto the heap? So it's doing 0, 0. This one is evaluating this thing. So it's evaluating the cost 1 to go, cost of 1. Oh, this is A to C. C is other. And the new cost from that is 1. Actually, that's maybe the heap should have started with all the original neighbors to the start, because I'm actually not sure how this thing ever triggers. Maybe it just doesn't. Does it? Okay. I think this should be, this is initialized to the wrong values in the heap. So the start is for every kind of start connection to the start. Or I guess I'll just call it neighbor. For every neighbor in range 26. Guess it should be heap is empty if neighbor not equal. I guess I could just do this comprehension here, I guess. The heap is composed of the cost, which should be low cost from the start to the neighbor for every neighbor in range 26 if the low cost of the start to the neighbor does not equal infinity. I think that's the list comprehension way of writing this. This should be a tuple. Low cost start to neighbor, common neighbor tuple. For every neighbor in range 26. I guess this is probably fine. Yeah. And then I should probably set at some point. Then I need to heapify this. Heapify this heap. And maybe at some point I need to say low cost of start to start is equal to 0. Or I could just do that here. Keep infinity here. Who cares? I think either way is fine. Heap push 2 arguments instead of 1. Heap push, oh my god. Yeah, this thing never even triggered. This error should have been caught earlier. Okay. Alrighty. That's scary. Okay, 0 milliseconds, nice. 0 times some number of test cases is small. Wow, 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 wow. That was not the easiest mediums. In the end, I think maybe I just outthought myself. Okay, so can I refine this? Length offset, starting letter, ending letter. Did I need to sort this? I don't know if I did. Did I ever even use tups? I don't think I did I? Yeah, I don't think I ever used tups, so I think this is all kind of wasted. Did use the low cost matrix. So stored into the low cost matrix the smallest cost from starting to ending. I'll just call this start to end. Start index letter and index letter. Never use tups. Then for every starting letter, create the heap. Yeah. I wonder if there was a better way of handling this so that I didn't have to iterate over 26 times. I think it would have been some sort of default dictionary with a list. Iterate over that list. I think that would have just been as tedious in some other way. Equally tedious in some other fashion. So then there's that. Okay, I think this should probably be the same speed, if not slightly faster because I got rid of the extraneous sorting stuff. Probably slightly slower than last time, just because randomness probably. Oh, it was slightly faster. Okay. Okay, summary here. So overall problem was was very similar to approach of handling shortest path in finding shortest path between start and end nodes in a directed weighted graph. Slightly, or definitely harder because need to optimize or need to find shortest for every node combination rather than set nodes like IE or EG, A to Z. In general, when dealing with this type of problem, need to have some structure to hold the lowest path cost, lowest cost for path found for every lowest cost for path. In this case, I used a matrix, cost matrix. I guess I called this the low cost matrix rather than the cost matrix cost array that was given. And heap to traverse with traverse nodes by analyzing lowest path cost first and a process to update the paths when something better is found. So in above, the general breakdown is one. I think I converted the cost array to cost matrix I guess cost, original, and changed arrays. To low cost matrix. Low cost is kind of a transition matrix where matrix row column is equal to matrix the original letter is the row, changed letter is the column, and this is the cost to do that transition. Since it was possible for a path for duplicate costs for original to changed, kept track of lowest. Because in theory, the description of the parameters, it could have had like A to B cost 5 and A to B cost 10, A to B cost 100, kind of duplicate or different pathings to the same, between the same source and destination. So yeah, just iterating over that, just creating that matrix. Obviously it's a 26 by 26 matrix. And then part 2 from there was iterating over the heap. Part 2 was for each, consider every starting letter, every letter, consider each letter one at a time as the kind of as the start letter. Update all, try to find the lowest cost path from start to every other letter. Use a heap that has tuples of costs or kind of total path cost and then the end letter. Process heap by updating costs if not already outdated, and looking at neighbors of the end letter and comparing if start to that end letter is if current low cost of start to end letter is bettered by current path to end letter. If so, push onto heap that tuple. And then after heap is fully processed, low cost matrix should be fully updated. It should be updated to have the shortest or the smallest cost between every start and end letter. And then part 3 is just use the low cost matrix to determine the overall cost of changing the original to Was it the source? Changing the source to target. If any start end has cost of infinity, means not possible, and return -1. All right, so yeah, processing the heap start is going to be a nested for loop. The outer for loop is the iterating through the start letters. The heap starts with just the neighbors that start letter. So like if it starts with A, then it just has A to B and A to C on the heap. And then yeah, heapify low costs. I just make this to say that the cost of transitioning from the letter to itself is 0, but there's other ways of handling this. When you process the heap, you take the top of the heap, which just has the lowest cost, lowest total path cost. If this is possible that there was some other pathing to this thing that made it smaller. Actually, I don't know if this is ever hit. This might never be hit. Yeah, this might be redundant, to be honest. Anyways, update. I'm not sure if you even need this either, because this kind of happens over here. I don't know about these 2 lines. Anyways, for every other neighbor in range 26, see other being basically what's connected to the current, where the current is already the neighbor of the start. If it's not the start, and if the other is not equal to current, or if it is the start or the current, then just skip it. Or if the cost to this other is infinity, then skip it because there's no connection there. And then the part is like going, like, let's say C to Z. So C to Z is going to be something. And the total plus part is less than the stored start to this other. Then update and push. Anyways, I'm tired. Time complexity is going to be I want to say, what is this time complexity? It's kind of fixed cost, to be honest. It definitely does need to process through everything in the, I think it's probably O of M plus N, where M is the length of the kind of source. Actually, is it called source? Is it source slash target? And N is the length of the original slash change slash cost. Since you need to have a for loop that iterates over each of those at some point to calculate total cost and to calculate the original low cost matrix. But the low cost matrix, I think I want to say low cost heap nested for loop, that whole main thing is kind of is maybe O of N. I'm really tired. There's a lot of fixed costs. Involved, since it always builds a 26 by 26 square matrix. Alright, whatever. Space complexity. think this is also O of, it's O of, yeah, it's O of 1, since low cost matrix is always 26 by 26. Guess heap might be O of n, since it grows in size with the number of edges defined by the cost array. All right, whatever. Which algorithm